Welcome to our third discussion. Today's discussion is going to be on section 2.1, velocity and tangent line problems, and section 2.2 on the definition of a limit. In this video, we'll be reviewing secant and tangent lines and doing a practice problem. So let's start with some function y equals f of x, and I'm going to draw a graph. So I'll draw some axes, and then let's start to draw a graph, and let's just say that my graph looks something like this. Alrighty, and I'm going to label some x value like 2. So label some x value and draw the point on the graph where 2 is. Okay, and then a little bit further down the road, I'm going to draw a point at 3. So it's definitely not to scale, but I'm going to draw this point on the graph where 3 is. And so we have these 2 points. So ultimately what I want to be able to do is to draw a tangent line at 2. So I'm going to begin by reviewing what a secant line is. I'm going to connect 2 with this nearby point at 3. Okay, and when I connect 2 points on a graph, that forms a secant line. So a tangent line, when I draw a tangent line at 2, that tangent line should kind of mirror how steep the graph is, what the slope of the graph is right at that point where x is equal to 2. So the secant line gives me an estimate of the slope of the tangent line, but it's not perfect. If I want to make it better, I can move the point that I have where x is 3 a little bit closer. So let's say I pick a different tick mark point here. Let me put it in a different color. Let's say that this is 2 plus a little bit, 2 plus h, and I label that point. If I connect that point with a secant line, our secant line will be a little bit flatter. So this one we have 2 secant lines. Here's 1, here's 2. And if I were to now have h approach 0, get closer and closer to 0, our secant lines will approach the tangent line. Okay, so now to draw the tangent line, I can sort of see that if I move this point that's at where x is 2 plus h closer and closer and closer to the point where x is 2, my secant line is going to flatten out. So to draw my tangent line, I got to draw a line that sort of matches how steep the graph is right at that point. And the graph seems to be pretty flat, but slightly upward sloping. So something like this. This would be my tangent line. All right, so that was a bit of brief review. Let's get into an example now. So I want to look at one of the problems from worksheet 2. It's question number 3, where we have the function b of x equals 1 over x. And part A asks us to find the slope of the secant line between the point 2 comma b of 2. So that's the point where x is 2. And then a bunch of other points where the x coordinate's 3, where it's 2.1, 2.01, and so on. Part B is going to ask us for some more slopes of secant lines. Well, let's get a feel for what this is asking by drawing a picture. So this is a good chance for some review of the graph of 1 over x. Okay, so the graph of 1 over x, remember this has like a hyperbola shape. So there's one piece of it over here, and there's one piece of it over here. All right, and one of the points that we're focusing on is the point where x is 2. So the point where x is 2, I'm going to draw that. And if I plug 2 into this function, the y coordinate is going to be 1/2. Okay, so that is the point where x is 2. And I can call the y coordinate b of 2. But b of 2 is just 1/2. And in part 1 of A, I want the slope of the secant line between that point and the point 3 comma b of 3. So I'm going to draw a tick mark where 3 is. So that's going to be the slope of the secant line connecting those 2 points. In the next part, I want it from up to 2.1. So 2.1 is super, super close. So I'll be getting the slope of the secant line connecting 2, where x is 2 and x is 2.1. And I'll get it closer and closer and closer. And then if we look at part B, it wants to do it from the other side. So in the first part of part B, I want the x-coordinate to be 1. That would be somewhere over here. And I'll get the slope of the secant line connecting that point in where x is 2. And then in part 2 of B, I will make it way closer to 2, get it to 1.9. That's somewhere here, and I'm going to join a secant line between that point and the point where x is 2. All right, so let's work this out, but I'm first going to give you a chance to try it. So pause the video for about 3 minutes to try this one on your own. You'll probably need a calculator to work out some of these values. 4, 3, 2, 1, pause it, and try this one for about 3 minutes. Alrighty, so hopefully you did that. Hopefully you tried it for about 3 minutes. Let's talk about it together. So I'm going to make a table of values where I keep track of the other point that I'm connecting 2, comma, b of 2 with, and then the slope I get for my secant line. The slope of the secant line. So let's zoom it out a little bit so I can see the whole thing. All right, so what are some of these other points? Well, I have 3, comma, b of 3. Then we'll do 2.1, comma, b of 2.1. Then we go even closer, 2.01, comma, b of 2.01. And then we go super close, 2.001, comma, b of 2.001. And then let's also do the ones in part B. I'm going to write 1, comma, b of 1 at the bottom here, because as I move up, I want to do things that are closer and closer to 2, just so I can, see it kind of sequentially. All right, so above that, I'll do 1.9, comma, b of 1.9. So getting closer to 2. And then 1.99, comma, b of 1.99. So far, I'm just organizing my work a little bit. And then I'll do 1.999, comma, b of 1.999. Alrighty, so we are doing part A up here, and then we're doing part B up until here. All right, so let's write down the slopes of some of these secant lines. So for 3, comma, b of 3, remember my formula for the slope of the secant line is the change in y over change in x. So using the slope formula, so I'll get b of 3 minus b of 2 over the change in x, which is 3 minus 2. If I plug 3 into this function, into 1 over x, I get a third. If I plug 2 in, I get a half, and then over 1. And simplifying this, I will get negative 1/6 if I get a common denominator. Alrighty, so let's do the same. Let's do the same type of thing for the next point. Alrighty, so I just spaced it out a little bit here. So let's get into the next point. So now if I plug 2.1 in, I'm just going to jump straight into it. If I plug in 2.1, I get 1 over 2.1 minus, if I plug 2 in, I get 1 over 2. So that's the change in y, subtracting the y coordinates over, now I subtract the x coordinates. One of them is 2.1, one of them is 2. And I've plugged this into a calculator ahead of time, and I'm going to round it to 4 decimal places. And I get negative 0.2381. Okay, I could do the same type of thing for the next point. Again, I'm going to give myself a little bit more room. For that one, if I plug in 2.01, I get 1 over 2.01. If I plug in 2, I get a half. And then over, subtract their x's, 2.01 minus 2. I've rounded this to 4 decimal places, and this is negative 0.2488. All right, so for the rest of these, I'm not going to write out this whole fraction. I'm instead just going to tell you what we end up getting after we plug it into a calculator. So this next one, I'm just going to put a squiggly line. You plug it in. This one ends up being approximately negative 0.2499. And now from the other direction, let me start at 1, comma, b of 1. When I plug in, this is exactly equal to negative 1/2. Then for the rest of these, I'm going to round. For this one, to 4 decimal places, whoops, I should put approximately equal to, because I'm rounding. negative 0.2632. The next one is going to be approximately negative 0.2513. And then finally, this next one is negative 0.2501. Alrighty, so finally part C now says, well, using the answers we got in the previous parts, estimate the slope of the tangent line at 2. So we have to look at these numbers, part C, and see what they seem to be getting closer and closer to. When as I get close to 2, they seem to be getting close to negative 0.25. So as x gets closer to 2, the slope of the secant line, the secant line approaches. This approaches negative 0.25. All right, so let me box that. And that is going to be our answer to C. This is what we will estimate. This is our estimated slope of our tangent line. And eventually, once we talk more about limits and how we can evaluate them algebraically, we'll learn a way for us to figure this out exactly.